All right, guys. So now what we're going to do is start looking at how to prove triangles are congruent. We talked about congruency, what congruency means, and now we're going to focus specifically with just triangles. Okay, and this is one of the cruxes of geometry that we're looking at. Now, when we're talking about proving triangles congruent, first you're probably thinking, what are you talking about proving? Well, there's something in math called proofs that we have. Okay, and a proof, what is it? Well, basically, like in your English class, when you start doing what's called persuasive essays, and you have those 3 different ways to appeal to people, well, the one that we focus on in math is going to be the logos. So that's exactly what we're looking at. It's almost like a persuasive essay that you would do in English, where you need to have some statements, you have to have evidence, you have to be able to back up what you're saying. So it's a logical argument. That's pretty much what it is. So how can you logically argue with somebody to say, well, this triangle is congruent to that triangle? Now, a proof you can use not just with triangles, but because, again, we're focusing more on the triangle aspect, that's what we're going to do here. Now, there's 3 different types of mathematical proofs that we really focus on. The first one is called a 2-column proof. And most of the time, this is what we use. So with the 2-column proof, you pretty much have 2 columns that are created. You have one side, which is for statements, and you have the second side, which is for reasons. So you may be given a problem or something to prove, as is noticed above here. It says, given certain information, you're trying to prove that the 2 triangles are congruent. Okay? So then we divide up, we say statement column, a reasons column. And then you notice that we number them. So as we're numbering them, we say, this is my first statement, this is my first reason. Here's my second statement, here's my second reason, and then so forth and so on. Okay? The second type is a paragraph proof. So if you enjoy writing paragraphs, this is for you. You can still write a proof. It doesn't have to be 2 columns, but more of in a paragraph form. Now, when you write it in a paragraph form, you still have to make sure you have the right connectors, just as if you were writing a paragraph in your English class. So it's really no different. Okay? And you will end up coming to a logical conclusion by the end. And then finally, we have something called a flow proof or a flow chart proof. Depends on who you're talking to about how they name this. But basically, you'll see it's like a diagram. So this is really more of a visual type of way to prove something. So if you notice, you'll have your statements that are inside maybe circles, ellipses, rectangles, different shapes or whatever. And your reasons for your statements are actually usually below or outside of that. So like you'll notice where it says C is the midpoint of BE, and then underneath it says given. But then what you do is you follow the arrows, and as you follow the arrows, they connect together to give you the next statement that you're going to make. And if you notice that all 3 of the arrows from these, they all point to that bottom figure there to be able to come to your final solution of what you're trying to prove. Okay, so now when we're proving the triangles, we're going to more or less look at the 2-column proof. Okay, again, you can transform all of these into any of those different types of proofs. And if you prefer one over the other, then that is perfectly fine as well. So first, let's review again, what are the 5 congruency shortcuts? We have side, 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 angle, angle, side, angle, 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 side, and the hypotenuse leg. Okay? Now, we keep these in mind because these are the goals of what we're trying to get. We're trying to use shortcuts because if you're trying to prove 2 triangles are congruent, remember that you have to have all 6 parts of one congruent to all 6 parts of the other. But because of these shortcuts, if we can find these 3 specific parts are congruent to those other 3 specific parts by using these, we can get to a congruent triangle a lot quicker. Some of the different properties of congruence that you need to make sure that you know and have down are the reflexive property, which basically says that if one thing that you have is congruent to itself. Then you also have the symmetric property. Symmetric is going to say basically that you can balance or flip things around. So if I say angle 1 is congruent to angle 2, then that means angle 2 is congruent to angle 1. And that's just the symmetric property of congruence. Okay, and then finally we have something called the transitive property of congruence. Now these are all different types of properties that are similar to equality. Now, transitive property of congruence is basically saying if A is congruent to B and B is congruent to C, then that means the first thing that you had has to be congruent to the last thing. So A would have to be congruent to C. And that's because both A and C are congruent to B. If you remember when we were doing the substitution method for the systems, it's the same idea. Sometimes we would say that y is equal to something and y is equal to something else. And then those two something else's were equal to each other. Hopefully that kind of makes sense, what I'm talking about. So here is an example for us to walk through. So I'm given this information and I'm trying to prove that these two triangles are congruent. So again, all right, what is my goal? I think about what's my goal. My goal is to prove that the two triangles are congruent. What does that make me think about? It makes me think, okay, are there shortcuts that I could use to make this go faster? So I think, okay, here are my shortcuts. Angle, angle, side, angle, side, angle, side, side, and hypotenuse leg. So those are all my shortcuts. So now as I'm trying to construct my argument here, I need to think, okay, well, I should probably start with what I'm given. Okay, so that's what you do. You start with what you know. What are you given? Well, I'm given that angle BAC is congruent to angle DAC. And if you look in the diagram, it's marked for us. Next, I know that that line segment AC, right in the middle, is perpendicular to line segment BD. Why can I say that or make that statement? It's given to me. So I have two given pieces of information, and now I can develop it further. The next thing that I know I can say is that I know measurement of angle ACD is equal to 90 degrees, and the measurement of angle ACB is also 90 degrees. And that's because the definition of what it means to be perpendicular. That's my reason. So because two things are perpendicular, I know that they're going to form a 90-degree angle. So I can say that's my reason for it. Next, I can say the measurement of angle ACD is equal to the measurement of angle ACB, and you can say by the transitive property, right? ACD is equal to 90, ACB is equal to 90. So if they're both equal to 90, they have to be equal to each other. It's kind of a no-brainer there, right? Next, I can say that angle ACD is congruent to angle ACB. So if two things have the same measure and they're the exact same thing, so in this case, I have two angles that are measuring the same, then I know the two angles are also congruent to each other, okay? And so we just put that in as another statement because we're talking about congruency. We want to make sure we're looking at congruent parts that we have. So next, what do we need? Well, we know we have two angles that are congruent to each other. So what does that mean about our shortcuts? Well, with our shortcuts, we want to look at the ones that allow us to use two angles. So we have angle, angle, side. So if we could do that, if we could find a side, that would be great. Side, angle, side will not work because we have two angles. Angle, side, angle, that might work because we have two angles. And then side, side, side won't work. And neither will hypotenuse leg. Although you have two right triangles there, since you already have two angles that are congruent, there's no need to look at the hypotenuse leg piece because the hypotenuse leg is for knowing the sides and the legs. Dealing with the sides. So what I'm going to say next is I have that line down the middle, the line segment down the middle, and it says AC. So AC is congruent to itself. Remember those properties I mentioned earlier? The reflexive property. So that's why I can say AC is congruent to itself. And so finally, I would then have it's by angle, side, angle that the two triangles are congruent. So what I've been trying to prove is my last statement. And how do I make that statement? Because of angle, side, angle. Because that line segment in the middle, AC, is congruent to itself. Okay? So that is the proof for this. Next, we have another one. This one, it says to complete the proof by filling in the blanks, right? So I can look at my diagram and I look at my given, what I'm trying to prove. Okay, what am I trying to prove? All right, I'm trying to prove that two triangles are congruent. I can go through my head again. Okay, I got my shortcuts. You can write them down if you want. All right, next is, let's get started with this. Now, they've already laid out the proof for you pretty much, so it's not like you have to come up with it for yourself. You're just filling in the gaps. So what am I given? I know I'm given angle N is congruent to angle S. Okay, it's my first statement, the reason it's given. All right, my next one. Okay, now it says angle NQT is congruent to angle SQR. Okay, well, what are those? Well, NQT and SQR, remember the vocabulary from the lesson that you looked at prior to watching the video. It said that there are what's called vertical angles, and vertical angles are equal. So I can write that as a statement. I can just say vertical angles are equal. Now we have L bisects TR at Q. Okay, bisect was another word that you should have looked at, some of the vocabulary. So bisect, again, that's to cut something exactly in half. So it cuts it into two equal parts or two congruent parts. So if that's the case, if L, that line L is bisecting the segment from T to R, we know that's given. But what does that mean for that segment? That it has now been broken into two congruent parts. So T to Q and R to Q are going to be congruent to each other. Now, with all this given information that we have angle side is going to help us to prove that the two triangles are now congruent. So that's two examples of how to prove two triangles are congruent. I will go ahead and create another video that has a third example that you can watch if you'd like to have some further information. All right? I hope this helps you a little bit more.